what is the likelihood that you think we'll find evidence for life in your lifetime outside of planet Earth?
Evidence for life, that probably depends who you ask.
Right.
Because what is evidence for life? What would we consider evidence for life? Is it like a byproduct from life? We breathe out CO2. What if we find a planet that has a lot of CO2? Well, we know of lots of planets with CO2 that don't have life. Venus, Mars. CO2 is a pretty common molecule in the universe. So it's hard to like hone in on a single byproduct. But you could think of like multiple byproducts. What if there's CO2 and oxygen, which are both associated with animals and plants? Mm-hmm. And then methane, which is also associated with like the decay of things and a byproduct from animals. So what if you found all of those? All of these things are also naturally occurring, though. Like there's many ways that you can get methane, CO2, and oxygen that don't have anything to do with life. Something that is interesting is that oxygen, O2, and methane in the upper atmosphere, they combine and annihilate. So that would tell you that if you saw a constant supply of oxygen and methane, there must be something creating it.
Right.
And so like maybe that's an indication
Interesting.
that there was life. Because if all life ceased, eventually they would all annihilate and you wouldn't be able to detect them anymore. There's also this really cool idea of what's called the red edge. So, plants absorb the visible and UV light. This is what they use for photosynthesis, but they don't absorb red light. They reflect it. So if you think about what a planet that was covered in some sort of photosynthesizing organisms, it would have this red edge where it's brighter in the red part of the spectrum, the visible spectrum, and then has like this drop off where the plants are absorbing and not reflecting the shorter wavelengths of light.
So I'm actually curious about whether there's an assumption there about the wavelengths of light that are emitted by that specific star system, and if the like photosynthesizing plants on orbiting a planet on a different star system might absorb different wavelengths.
Huge assumption, which is like getting into it depends who you ask, because there are a bunch of assumptions there. That is behavior that we would kind of expect with the life as far as we know it and how it would have looked relative to our sun. But, there's no reason that photosynthetic life on another planet couldn't use all of the light that was coming from the star. Or maybe for whatever reason, it favors the red light, right? So it's like there isn't, we can get super creative and speculative, but it's just hard to pin down what the right investigative approach is, because you have to start making all of these assumptions.
Right. So all we need to do is find like one additional data point that suggests life exists somewhere else outside of Earth. Like something that I'm excited about in our lifetime is maybe sending, and I'm not sure how far out this is, but like maybe sending a rover that will sample Martian regolith, like Martian soil, and then something that will come back to Earth and show us. Or I guess you could just put a microscope on a rover, and then that microscope, like it'd be really fine-tuned instruments.
So there is actually a plan for the retrieval of the rocks that have been collected by, I forget which Mars rover, but my buddy, Dr. Alvin Smith, he's at NASA in Houston at Johnson, and he is one of the leads. I think he might be the head. He's one of the leads up in the leadership that is supposed to be putting together some of the stuff with NASA is obviously up in the air because there's like all these budget cuts and everything. But there are plans to retrieve the rocks that have been collected from Mars, which is super cool. Yeah. Dr. Alvin Smith, really cool dude too.
Interesting.
Yeah.
That is so cool, man. I feel like it's going to be either that or, I don't know. Do you think JWST, like James Webb Telescope, is equipped to actually resolve evidence of life?
In theory, it should be, right? It can't, when you say resolve, it's not like it's not going to be able to see planets that we would consider potential hosts for life. It can directly image larger gas planets. I think recently they actually they directly imaged a Saturn-sized planet. But this is for a relatively young system. So it's like a hot gas giant. So, this is not the type of planet that we would typically probe for life. But in theory, James Webb Space Telescope can do atmospheric spectroscopy. So you think about a planet orbiting a star, and if it comes in between you and the star, it'll block out some of the light, but some of those photons are going to go around the disk of the planet, go through the atmosphere, and come to you, and should get absorbed by whatever's in the atmosphere. So you could potentially find like biosignatures. And, this sort of spectroscopy has been done on a lot of planets. The problem is, if we're thinking about Earth-like situations, you're really talking about a small planet that has relatively thin atmosphere. We don't think about this on Earth because obviously we breathe the atmosphere. We talk about it. The power of like even a little bit of extra CO2 in the atmosphere can change the face of the planet. But if you look at a picture of Earth from space, the atmosphere is really paper thin. It's a very, very, very small atmosphere. If I were studying an exoplanet that was similar to Earth and were dozens of light years away, I would probably just say that this was a stripped rocky planet that didn't have a significant atmosphere. And that's because it's hard. We have not demonstrated the ability to detect a Earth-like atmosphere. Right. It's too hard. You just don't really see anything.
Right.
But that was the hope for JWST, and I mean it still is. It's still possible. The TRAPPIST-1 systems have been observed, and it doesn't look like any of them have significant atmospheres. But I wouldn't be surprised if they all had thin atmospheres. Like I said, if they had an atmosphere like Earth, it's not clear to me that we have the ability to detect it currently.
That's so interesting. And so, I mean, what is the limiting factor there, like technologically? Like, is it literally like the size of the mirror, like those unfolding golden mirrors that JWST has? Like, they just need to be larger? Like,
yeah, well, a larger telescope always helps. But
why? Why does that help? Is that like kind of the same way that cameras work? Like, just like the wider, the larger the sensor is, the more light is let in?
It's a little bit different than cameras, but it's similar, right? So if you think about resolving, let's try to like build up this understanding conceptually. You think about resolving an object, right? So what is the object actually doing? It's like either reflecting or emitting light. In a planet's case, it would be reflecting if it were like a small rocky planet, but if it were a larger gas planet, then maybe it's emitting. So if you want to build a picture of it, what you need is a telescope that's big enough to collect enough light, which remember is being spread out as it travels, to reconstruct an image. So you imagine like a star that's extremely, extremely far away. The reason that you need a huge telescope to resolve that star beyond a pixel is because all the light is being spread out. So you've kind of got to like gather a large amount. And this is why, if you wanted to resolve like an Earth-like planet that was extremely far away, you would need a telescope that's like larger than the solar system or something. Because the further away something is, the more that light has spread out. And to reconstruct the image, you've got to be able to bring it all back in. So we can, for nearby planets, like the Habitable Worlds Observatory, which is being worked on right now, we do think that we'll be able to actually directly image Earth-like planets at Earth-like distances around their stars, at least ones that are nearby. But it's, you have to be able to kind of pull back in all of the light, and the distance that you are away from something increases the like spread of that light.